Okay, so hi, I'm Denis Gagné from Trizatech, and with me is John Zverberly, our Chief Medical Informatic Officer. And we want to talk to you today about healthcare concept maps combined with FHIR Accelerator in the context of BPM Plus Health. So our point of view over this interoperability game is that we think that a modern healthcare integration toolkit should support various kinds of integration. And particularly here, we're listing API-based integration, event-driven based integration, but also semantical-based integration. So Trizatech has been on a healthcare journey for a few years now. The first phase of our journey was mostly focused on looking at how we can create BPM Plus Health executable models that were platform-independent models. So that was our main first focus in phase one. And then we took these platform-independent models and put them in a FHIR wrapper, so a FHIR-specific wrapper, to have them run against FHIR database and data stores in various environments, and using CDS hook that were generated on the fly. Today we're going to talk about phase two of this work that this journey that we've been on, and talk about how we can create concept models or concept maps of most commonly used condition and observation, looking at semantical disambiguation of these terms using coding, and then looking at a FHIR accelerator to enable the creation of wrappers in a more effective and faster way. Our phase three that is already outlined, but we're not yet initiated, is to look at having FHIR endpoint being generated on the fly directly from the BPM Plus Health conceptual model. So that's the next phase we want to address. So I'll pass it to John now to talk about our experience with phase one.
Thanks, Denny. I think one thing that BPM Plus is facing is at least in authoring, is the need for maturing the process. Up till now, many of the models have been one-off. A certain project would come up, someone would do it, but there really was no integration with the larger community. And as Phillips has indicated, there will be interest in people sharing models. The consequence of that is the random artisan approach needs to be replaced by a more of an engineering approach, where standardized terms and software are used to make these more effective. And if you go to the next slide, Denny, I think just this is out of, we did a survey of 667 DMN models, and this gives you an idea of some of the numbers of things that are generated. If you take a large number of models, there is a much larger number of shapes, and then the various types of FHIR calls that you need to make also becomes large. One consequence of not having standardization is that one author might use the same name for a data object, may have multiple different names for the same one. Also, different authors may share the same name. And so when the engines are faced with this, they will try and merge numbers, which can have unexpected side effects. Back to you, Denny.
Okay, so in doing this phase one, as John mentioned, we created over 1,000 models, of which 667 we exposed as service. So we had a lot of learning experience in doing these models, putting them in the wild. And some of the best practice that came out of this is how do we move from a narrative of a clinical guidelines to a platform-specific model that is executable against a physical system. And we followed the OMG best practice of moving from a computational independent model to a platform independent model to a platform specific model. So this allows us to have separation of concern where the narrative is really textual. The computational independent model provides us with the behavior specification, how we want things to happen and to behave. Then the platform-independent model provides us with the executable logic, so we're at the logical level, but still executable. And then finally, we move towards the target, the physical system that we want to integrate and run to. So the approach we were taking is that we would create BPMN, CMMN, and DMN model, both for the computational independent model and the platform independent model. And then we would transform these or convert these into FHIR-enabled BPMN, CMMN, and DMN services. Now, if you look at the graph or the diagram there, there are gaps in there, and these gaps need to be filled. How do you go from one stage to the other? How do you progress through these stages? And fundamentally, the first answer and current answer is we use the subject matter expert to basically bridge those gaps as you're progressing through. So we wanted to know what needs to be done at each level to see how we can better tool and enable this to make it simpler for the subject matter expert to do that work. And basically, the first gap going from the narrative to the computational independent model really requires the capture of narrative into models. So that's the task to be done. Then when moving from the computational independent model to the platform independent model, we need to add the notions of data type and logical expressions. And then when moving from the platform independent to the platform specific, we need to add binding that are specific to the data source. In our case here, the FHIR data source, or the FHIR wrapper, that, as we call them in our practice at TriZetech. So I'll pass it on to John to talk a little bit about the kind of skills that comes at each of these levels.
Thanks, Denny. If you look at, here's some listing of some skills that are required, and they're basically capture the narrative for the models. There's a barrier to entry because people have to learn how to do this modeling, usually through a course such as the method and style training done by Bruce Silver. Then after you've built the models, you need to flesh them out, which takes a little bit more effort. And finally, then you need to take the models that are built and then prepare them so that they can be ingested by the host system. Next slide, Denny, please. So we had a couple theories when we were starting to look at our data. One of which was, is all data created equal? Or is there a certain distribution of how data is used that could impact the type of solution that is needed? And the solution well, the principle that Denny proposed was that the Pareto principle, which states that roughly 80% of the consequences come from about 20% of the causes. So there's a core set of data that gives you the biggest bang in a process. Next slide, please. And so this is a representation for FHIR observations that were made out of the 667 models. There were approximately 1,400 data calls with 331 separate data items. And when you analyze them, there were 50 items that represented almost 3/4 of the usage. It also was that 2/3 of the data was only used once. So this sort of information is useful for people doing the integration because most of their effort will be integrating that small number. So if we can make their life easier, you have become a far more efficient operation. And then you can focus on these one-off type data items. It also gives the clinicians information because their data sets that they try and collect the data can focus on those areas that are most widely used. Back to you, Denny.
So in order to address this, we started looking at how we could build concept models of the most common used terms. And concept models are basically working at the level of the concept, so the terms and their meaning and how we can disintegrate them. So here you can see some of the terms for cardiac measures and how they interrelate into the structure and how these can be disambiguated. with coding. So basically, we're able now to take this concept model and provide a definition, and then provide both a coding for disambiguation and also add the logical structure that is expected for that concept. Now, that concept is still logical. It's not physical to a specific system. It's still logical and allows us to map it to different concrete system environment. So then we can reuse these these concepts right into the model. So here's an example, for example, of a DMN model for curve 65 score, and where you can see that the terms, the concept are reused. Those that are underlined in red here are reused concepts that are disambiguated. And by mousing over, I can get the definition of that term, and I also can have access to the actual disambiguation of the term. The second hypothesis we went towards was, how can we help, bridging the gap to FHIR? Because we felt that was the biggest gap for our subject matter expert that are more clinicians and medical in training and maybe not informatician and don't have the FHIR knowledge. So what we did there is we created a FHIR Accelerator that basically allows you to do a drag and drop of any resource from the FHIR structure right onto the canvas. So the person doesn't have to know anything about the structure. They can just drag and drop and then accelerate this path. And this provides you for this observation. For example, here's an observation where I can go down all the way to the value, quality, quantity, and the value right in there into the FHIR structure. So what we're hoping that we showed you here is the approach we've taken to close some of those gaps, maybe not close them completely, but at least provide tooling to the subject matter expert to accelerate their work. So when they move from narrative to computational model, they have a full collection of most common observation and conditions that they can just use and reuse easily and are all disambiguated. So that gives them acceleration to using a common language that is disambiguated. Then when they close the gap from computational independent to platform independent, they have in that same disambiguated models of concepts, they have the logical type, and that allows them to write logical expression and different logics according to that. And then when it comes to doing the binding for FHIR, they can just drag and drop the FHIR element and then just connect directly to what fits, basically do a mapping from within the platform independent model to the platform specific model. So hopefully we've convinced you that our experience have shown where those gaps are, and we think we have a good concept of how we can close those gaps. And by the way, I didn't mention it, but fundamentally, for those of us that are working in the BPM Plus Health group, this gap here is the gap that is basically being addressed by the SDMN standardization effort that we're starting. So it's basically this one gap here that SDMN is looking at addressing. So let me show you a little bit of this live, if there is such a thing. So you can see here that I am within the concept model, and I have these different terms. Then I can jump into one of the concepts. And this here gives me the access to the definition, whatever node. And here I have my logical structure. This is a number without specifying the structure of the number. And I can see the coding. This particular term has been disambiguated by the loin code. It could be a value set, could be a series of codes. It's whatever you want to do. And then you can reuse these terms within the models. And so, for example, here, because all these terms are being reused, I'm reusing concept, then Whenever I reuse them, I have access to the definition. So it allows everybody to use the same terminology with the same meaning when they're doing their model at the conceptual level. And by bringing in the data type structure, for example, in here, this logical data type here that says that the respiratory rate is a value between 0 and 200 here in this case. And then let me move this widget if I can. No, I cannot. So how do I get to this? Oh, there you go. Thank you. And then when it comes to accelerating the FHIR wrapper work, then you can just work through the structure that reflects the FHIR R4 structure here. So I can either go into foundation or clinical. Let me go in clinical here. If I go into diagnostic and I take the observation because it's the one I've showed there, when I bring this element here, then what I have is a fully, it takes a little bit longer when they are screen sharing. I don't know why, but it does. Then I have a fully, this structure of the logical information. So here you can see that this object here is an observation. It's a FHIR R4 observation, and I have access to its structure of the type, and then I can go and navigate the full structure down to the elements. So that was our presentation, a little bit similarly to the previous group. During the fall over time, we can address some question if there are some questions for us.
Denis, one quick question around the FHIR connections and drag and drop. Can you use profiles as well as resources?
Yes, so we're looking at bringing in the profile in the conceptual level instead of in the FHIR structure, because most FHIR profile, and again, I'm a neophyte in FHIR, but most FHIR profile are more aimed at constraining the typing, the logical typing, and the value of the enumeration. So it doesn't change the structure, it just basically reduces that set.
Well, most of them also have extensions, though. That's the problem,
Yes.
right?
Yes. Well, that's...
Yeah, and getting access to the data elements in the extensions is the challenge.
Yeah, so our aim right now is to bring these in at the conceptual level and have that percolate through, because we feel we'll have enough information between the conceptual disambiguation and the profile to actually map automatically in FHIR. That's our assumption for phase 3.
It'll be interesting to see how that pans out.
Yes, I'm interested in it too. Any other question in the last minute or two I can address, or John can address?
Denis, this is Bas speaking again.
Yes, Bas.
Very nice presentation. And actually, it somehow seems that you're very much ahead of what we're trying to do in the research work. So I was wondering if we could somehow, I would be happy to explore if we can model the use case that we had used in our exercise in Philips in the way you propose, in both in your modeling process, so to say, and also maybe in the tool to see how it helps, because I think it's very close indeed to what we're trying to achieve.
We're always looking at sharing and learning from everybody that's doing this kind of work. We've been heads down doing a lot of work ourselves, but other people may have different learnings or lesson learned that we'd like to apply into this. So yes, please do reach out. And the community at large. I mean, you'll see, Bas, that this community is very open and sharing everything that they're doing in their own perspective.
Yeah, well, we'll definitely reach out, and yeah, we're quite new to this community, so we're trying to find a way.